For your entire lives, anytime you've come across a number in a math problem, it has been a real number. Real number has been our word for just really all the numbers out there that you've used before. They can be anything from crazy looking square roots with awful decimals, to numbers like pi, to negatives, to decimals, to zero. Pretty much any number you've used in a problem in math has been a real number. And it's always been like that was all there was out there. It's kind of, you've really had no reason to assume otherwise. But it turns out there's this whole other system of numbers out there called imaginary numbers. And imaginary numbers are kind of hard to wrap your head around because it doesn't seem to fit with what we already know and understand about numbers. We kind of take this thing, like what happens if you square a number and got a negative? We take this weird idea and we use it to develop an entire new system of numbers. Numbers that are perfectly valid, you can use them in problems, and you can actually use them to get solutions. I won't pretend to know anything about it, but the field of quantum physics actually takes imaginary numbers, uses them in problems, and gets answers that work in the real world. So imaginary numbers are valid, they're useful at times, and they have their own rules that we're going to go into starting with this video. But there are two real ways you'll see imaginary numbers written. The most common, well, I don't know which one's more common than the other. You'll often see them with negatives under the square root like this, and you may also see them written with an I in them. So these are two forms, two things that kind of tip off to you, yeah, I'm dealing with an imaginary number. So before, real numbers were everything. If I said real number, you knew it could be just any sort of number you'd worked with before. But now, imaginary numbers are something else. So I need a new word for absolutely everything. So every number, imaginary and real, is included. Complex numbers is a complex number is the answer to this. Complex numbers is like everything. It's the real numbers and the imaginaries combined. So the reals and imaginaries. I don't know how you spell imaginaries. I think it's a made-up word. Imaginaries combined. So basically, both of these categories together form complex numbers. And the way you'll generally write a complex number is in this form right here, a plus bi. So the a is your real part. It's going to be just a plain old number. And the bi is your imaginary parts. I will give a couple examples of this on the bottom of my slide here. So for example, I may have a number like 5 minus 4i. This is a complex number. It's got a real part, just a plain old 5 there, and it's got an imaginary part, the minus 4i. We kind of combine those into one number, and we call it a complex number. So if I wanted to, I could say a equals 5 and b equals negative 4 on this one. I could do something like negative 3 plus 41i. Another complex number. We have a real part and imaginary parts. We could label a and b if we wanted to. So yeah, these are examples of complex numbers. Now, let's say I took a number like 7. You may think, well, 7's not a complex number, that's just a regular real number. But you could write 7 as 7 plus 0i. So every real number we've ever dealt with is actually a complex number. It's just that b has always been 0. Now you wouldn't teach a second grader or a third grader, well, 7's really a complex number. There wasn't any reason to bring it up then. But just realize you can write numbers like this as complex numbers just by making b 0. Similarly, if I just want to do like my 3i from earlier, that's really 0 plus 3i. So just imaginary numbers have a equal to 0. So anyway, that's a complex number, and we're going to talk about different things you can do with complex numbers. In this video, we're focusing on adding and subtracting them. Adding and subtracting complex numbers is actually very, very doable. And as a matter of fact, you know how to do it already, even though you've never seen this before in your life. That's because all you're doing is combining like terms. So your i's in this problem right here, treat them like they're x's. You're just doing math you already understand. So my parentheses here, there's nothing going on. Nothing to distribute. On this guy I have a plus 1 out front, so nothing changes. Once my parentheses are gone, I'm just going to combine my like terms like I've been doing for years. I get negative 13 minus 7i. That is the answer when I add those two complex numbers together. On my second problem, distribute into 1, nothing changes. Distribute it in a negative 1 to this guy, I get minus 2nc and plus 5i. And again, I'm just combining like terms, no different than algebra 1. 12 minus 20 is negative 8. Negative 2i plus 5i is going to be a positive 3i. In my final example here, I have a negative 1 outside my parenthesis. I just carry down my first part, minus 4 minus 2i. I end up with negative 4 plus 4i. So these complex numbers, we're going to learn different things about them. For adding and subtracting, it's really no different than combining like terms. So it's one skill that you can feel very comfortable in with relatively little practice.